Hello and welcome back. This is episode number 32. We're going to talk about I/O. So the past few we've been talking about applicatives and monads and all of these cool stuff, and we've been talking about specifically the future context. But today I want to show you the I/O context so that hopefully you can get an idea of when you might want to use it. So we have imported the usual suspects here, ramda-fantasy, and as always I'm Reed Evans. So one thing that you'll notice is a little different is when we call I/O, typically I/O is going to contain a function. It is some computation that is going to happen in the outside world that our code that we want to separate from our code. We want to have a representation of that computation, but not actually perform that. So one of the things we could do is we could have a log I/O function, which given some a will return an I/O of unit, because this is just going to console log. It's not going to do anything else past that. We could also then have, we could then call log I/O with hello world, which would then return us back an I/O. Notice that we haven't actually, if I were to run this, we haven't actually logged anything to the console. We've just defined what would be logged to the console whenever we actually run this I/O. One way to think of this is to say that if JavaScript were absolutely 100% pure, it would have no way to console log. And so one way you can think about this is we are putting a program here inside of another language or environment that knows how to actually do this. So I/O knows how to do things like console log. And JavaScript, in this case, we would be saying that if it were a pure language, it would have no notion of how to console log, but I/O does. So we're taking this function and we're throwing it in I/O so that when we have I/O go and do its thing, it will be able to perform this effect. So that's one way of thinking about it. And I got that, if you're interested, from the Pure Script by Example book by Phil Freeman, and I'll list that in the show notes. But that was a really neat way of thinking about that. So what can we do with this I/O? So one thing that we can do, we can do arguments I/O. So this is very similar to our console logging, but what we're going to do is we're going to go out and get the args from the process. Well, what's neat is that rather than just getting this and then always calling run I/O, which would kind of be a little bit pointless, this allows us to build up this computation throughout our application. So what do I mean by that? Well, as it turns out, I/O is a monad, it's a functor, it's also an applicative. And because of that, we can now create another function called log argument count, which is going to take arguments.io, which, as we see here, arguments.io is an I/O that contains an array of string. So we can map over that, and now x here that we're dealing with is an array of string. So we could say x.length, which will give us the number of arguments that were passed in. And then we can chain over that to log I/O. And then we're chaining here because we're showing that it's also a monad. So the map says it's a functor, the chain says it's a monad, and because log I/O takes some a and returns another I/O context, we want to chain here rather than map and then having to flatten again. So what does this all mean? Well, here's our trivial example. If I actually execute this and run it, you see that what we log here to our console is 2, because apparently there were 2 arguments that we had, and it got logged to the output, but only when I called run I/O. So I talked a lot about doing things at the application boundary. This sort of thing you could do at the application boundary. Everywhere else in your program, you're just building up a computation for what would happen when that I/O happens, when that I/O is actually run. So hopefully that helps. There's another little context here. So I think we've shown maybe map, maybe future I/O, and we probably saw some either too. So there's another one to look into. The big thing is it's typically going to keep a function, and we say that the I/O is, in this case, is an array of string, because this function returns an array of string. We don't have to say it's an I/O of a function from unit to this, and that's not the way that the implementation works for it. It's an I/O of whatever the return type is of the function that it contains. But we can still map and chain and all those good things on it because it's both a functor monad, and of course it's an applicative as well, which I haven't shown here, but it is an applicative, so you could do some other things there. Hope you enjoyed it. This has been episode 31, where we see some IO.